pick up where we left off, which is on practice test 2, and we're ready for the calculator part, where we are converting from degrees, minutes, or into degrees, minutes, and seconds, and then doing all of these, just typing them in problems, okay? So everybody sent me the practice quiz, the quiz, and got the practice tests out. We're ready to go. Okay, I need them sent because we are moving on right now. So I'm checking the time. It's 9:20. I need everything sent right now. If it's sent after 9:20, it's not going to count.
Which practice test are we on?
Number 2. So we're on practice test number 2, and we are ready for problem number 8. This is where we left off yesterday. Convert to degrees, minutes, seconds. All right, so I just type in 287.175. Then I go to second angle, DMS, and it gives it to me. So it's 287 degrees, 10 minutes, and 30 seconds. So I see no calculators out. No one is practicing with me?
Someone borrowed mine and then they didn't come into school today because of the roads. Like they needed mine last week.
That stinks.
And my good one today.
All right. Now, these are all just type-in problems. So who remembers what I warned you about or what I suggested you do when you get to this part of the test?
Measure calculators and degree.
Okay, so part of the problems are degrees and part of the problems are radians. So it really doesn't matter which group you start with, but do all of one group together. So right now my calculator's in degrees. So if I'm going to do the degree problems, I'll do B and D and F. Would everybody agree that B, D, and F are calculator problems? Are degree problems. Yes. So I'm going to do those first. So here we go. B. B is a cosecant. So when I type in a cosecant, it has to be 1 over sine. Okay? So I'm going to type 1 divided by sine, 183 second angle degrees, 21 second angle minutes, and then 3 alpha plus. So the answer, rounding to the nearest 10,000, the answer is negative 17.1087. 1 divided by sine. Now D is easy. D is just tangent, 321 second angle degrees, 58 second angle minutes. So negative 0.7822. Now those of you that don't have a calculator today, you probably want to practice these on your own and make sure you're getting the same answers. F is a secant, so I'm just going to type in 1 divided by cosine. That's what secant is, 1 divided by cosine. So 1 divided by cosine, just 23. So that one is 1.0864. And those are the degree problems. Okay? So now we go to mode and change our calculator into radians to do the other 3. And how do I know the other 3 are radians? No degree mark. That's right. So here we go. Second, I'm doing A. Second tangent, 1.375, 0.9420. Just type that one in. There's nothing tricky or special. Just type in what's there. Same with C. Cosine 1.75, nothing interesting there. Negative 0.1782. And then E is also easy. You're going to type it in exactly the way it is. You're going to press sine, and then 18, use your pi button, which is right above your divided by little caret thing there, over there in that far column, right under the clear button is your pi. So you're going to press pi divided by 77.6701. So there are the answers to that. So that should be very easy for you if you are practicing on the calculator. All right. Now we have these ones that are kind of like the word problems, only there's no words, you just have a picture. And we need to find x. Okay, so we're going to write an equation. So take a look at that picture. You think sine, cosine, or tangent? Tangent, absolutely. Opposite, adjacent. So we'll say tan x. Remember, the angle always goes with the tangent. So the angle's x, so it's tan x equals opposite over adjacent, 8/9. How do we type this into our calculator? Exactly, Courtney, thank you. X equals second tangent, 8/9. When the angle is the variable, we have to second tangent, or sine, whatever that is. Don't do any arithmetic. Do not multiply by 9 or do anything freakish. It's just second tangent, 8/9. Now, be careful. You're going to need to change your calculator back into degrees because there's a little degree mark right there. So my calculator needs to be in degrees. So second tangent, 8/9. That angle is 41.63 degrees. Now, we've got the same idea for this next problem, but x is in a different place, so we'll have a different equation. Okay, so look at that carefully. Sine, cosine, or tangent. This is your angle right here. Sine, cosine, or tangent? Sine. Very good. That's a sine problem because you have opposite hypotenuse. So sine 63 equals 12 over x. Now see how that looks different than what we had over here? When it looks like this, this is what we do. Here we have to do the arithmetic, so we multiply by x to get it out of the denominator and divide by sine 63. And that's what we type in. So 12 divided by sine 63, 13.47 is x. If this had been a word problem, we would label that. But since it's not, we don't. All right, so now we've got our compass. So what do we need to remember about labeling angles on the compass? Where does the 0 go on the compass? North. Straight up, that's right. So 0, 90, 180, 270. And your job is to draw 310. Well, where's 310 going to be? Right up here. That's right, JP, right up here. So you're going to draw 310. You're gonna label it just like this. 310 is past 270, right? It's between 270 and 360. So you just stick it up there somewhere. Came all the way around to 310.
That's all you have to do.
That's it. That's the picture. Okay. Now we're going to do this we have to do the same problem twice. So let's do it with the decimal first, because that's easy. That's with my calculator. And I just type in exactly what it says. You don't need to put in any parentheses. They just come in where they're needed. So cosine, second sine, 1 divided by 3. And decimally, it's 9.9428. All right, Katie?
When like you don't specify like where to round, 10, do we just always go to the 100?
Yeah, I should be more careful about that. I'll try to make sure I do that. But usually if I'm typing in a value on my calculator, like a cosine or a tangent or something, I do 10,000ths. But when I'm doing solve a triangle, I round to the nearest hundredth. But that's on me. I need to clarify that. All right, now exact. So that means now I'm going to do the same problem but without a calculator. So I'm going to draw a picture of it. Where am I always draw a triangle. Where am I going to draw the triangle? Quadrant 1. Because when I have this notation and a positive number, it's always quadrant 1. I'm looking only at the parentheses. Forget this for a moment. We're only doing the parentheses. So the sine is 1/3. Opposite over hypotenuse. Now, what do I always do when I have a situation that looks like this? Pythagorean Theorem. You've done it 100 times in the last few weeks. Pythagorean Theorem, so go ahead and do that. A squared plus b squared equals c squared. Square root of 8, which is 2 root 2. What?
Is it negative?
No, not in quadrant 1, it's not negative. If I were over here in quadrant 2 or 3, it would be negative, but that's a positive number in quadrant 1. Now, I have no idea what that angle is, but I do know what its cosine is. What's its cosine?
2 root 2 over 3.
Exactly. So there's your exact answer, and here's your decimal answer to that problem. Goodness.
My pocket.
All right, so number 13. Now we're going to do some word problems, and these all look exactly like the word problems we did yesterday. We got the squirrel in the tree, fish in the water, the airplane, flagpole, and the man looking at the building. All right, so here we go. The squirrel is sitting in the top of the tree. He's looking at a nut on the ground that is 52 feet away from him. Where does the 52 go? The nut is 52 feet from the squirrel.
Hypotenuse.
Hypotenuse. Guys, look. Here's the squirrel. Here's the nut. This would be the distance from the base of the tree. This is the distance from the squirrel. The angle of depression is 17.7, and we're never going to put our angle anywhere else. It's always going to go right there. And we want to find the height of the tree. So we got to write an equation. What will our equation look like? Sine, cosine, or tangent? mistake? Cosine? Sine, yeah. This is definitely a sine problem because this is opposite over hypotenuse. So sine of 17.7 equals x over 52. So x equals 52 sine 17.7. So we just type that in on our calculator. I think I'm in degrees, but I can't remember. Yes, I am. I just did a quick double check. 52 sine 17.7. So 15.81 feet is how tall the tree is. All right, now we have fish. 100 feet from shore. So that would be here, right?
I have a question.
Uh-huh.
When it comes to degree and radian and calculator, are we only switching between the two on like the evaluate questions like these that we did, or is there any other time we switch?
I think all the rest of our angles have been in degrees.
Okay. Thank you.
Okay, so the fish is 100 feet from the shore, and there's a seagull on a jetty that's 12 feet tall. What is the fish's angle of elevation? All right, sine, cosine, tangent. Definitely tangent. And it's going to be tan x, right? Because we always put the angle with the tangent. So it's tan x equals 12/100. How do I solve for x?
Multiply by 100.
When it is tan x,
Oh.
we do second tangent. Okay? These two are unbreakable. The only way to get x by itself is to use the inverse of the tangent. That's the only way you can do it. So second tangent, 12 divided by 100. Anytime, so it's 6.84 degrees. Anytime x is the angle, you're going to use this button, okay? Or inverse sine or inverse cosine. You're going to do an inverse button when x is the angle. Okay? That's the only time that's what you do, when x is the angle. Okay. Now we have the airplane approaching the airport again. Find the desired angle of descent. Find an angle. Right? Find an angle. If the pilot wants to land at a point that is currently 7,000 feet from the plane, and the plane is 235 feet above the ground.
Sine.
So does that picture, all that make sense to you? Jaden says sine. Is he right? Yep. So sine x equals 235 over 7,000. How am I going to find x now?
Inverse.
Inverse second. That's right. X equals second sine 235 over 7,000. You always have to do your second sine or second tangent or second cosine when x is the angle. So second sine 235 divided by 7,000, 1.92 degrees. All right. Two more on this one. Find the height of the flagpole. That makes the shadow 16.62 feet. when the angle of elevation is 64 degrees. Does that picture make sense to everybody? Is that where you put your numbers? Sine, cosine, or tangent?
Tangent.
This is a tangent problem. Everybody agree? So tangent angle, so tan 64 equals x over 16.62. So x equals 16.62 tan 64. How's come I'm not second tangenting or inverse tangenting on this problem? Because x isn't the angle, that's right. The only time I do that is when x is the angle. Okay, so 16.62 tan 64. 34.08. And the last one on this paper, what is the angle of elevation of a man? So here's the building. Here's the angle of x. What is the angle of elevation? Looking at the top of a building that's 48 feet tall. If he is standing 3,000 feet from the top of the building, where do I put the 3,000? Hypotenuse. He's 3,000 feet from the top of the building. Sine, cosine, or tangent? Sine. Opposite hypotenuse. So sine x equals 48 over 3,000. How do I type it in? Second sine, you know it. X is second sine, it's an angle, so it's second sine. 48 divided by 3,000. Ooh, tiny, 0.92 degrees. Lindsay?
Will any of these ever be cosine?
Well, what?
Will any of these ever be cosine?
Well, if this distance had been 48, that would be a cosine.
Okay.
So it just depends on what given information you have.
Okay.
So yes, it's definitely possible they can be cosine. All right, so guess what? Now we're on to the third one, which looks exactly like the other two, which looks exactly like your test, right? This is what we need to know. 2 pi over 5, how many degrees? Yep, how did you get that?
180 times 2 divided by 5.
Exactly. Pi is 180, right? So if I were doing it, I would do 180 divided by 5 times 2. She did 180 times 2 divided by 5. It makes no difference which way you do it. So that's 72 degrees. Perfect. Now, what about 100 degrees? How many radians is 100 degrees? This is a little bit more work. We have to say pi is to 180 as something is to 100. And then we'll cross multiply. These are the ones that we always have to simplify. So, yep, 5 pi over 9, that's exactly right. Because when you cancel the zeros, you get 10 over 18, which reduces to 5 over 9. And of course the pi is still there. Now, number 3 is the tricky one because it has to be done in 2 steps. So at first it looks really easy. You have a circle, the angle is 125 degrees, and the radius is 6 centimeters, and you're finding the arc length. And that seems like it's a very easy problem. But we have to remember that our formula for arc length is what?
Radius times radius.
Radius, which is all good. The radius is 6, that's good. But it's times radians. And this angle is a degree, right? So don't put it here. You gotta make that a radian measure. So aren't we gonna do exactly what we just did with 100? Yep, we're gonna change 125 now. So pi is to 180, as something is to 125. Okay, no zeros cancel, but you still need to reduce. So let's see, 5 goes into those, 5 goes into their 25, and 5 goes into their 36. You will be allowed to use a calculator to help you with your arithmetic. And I think that's all we can do, 25 over 36. Now, is that the answer?
No,
What do I do with it?
multiply by 6.
Multiply it by 6, that's exactly right. So I have 6 over 1 times 25 pi over 36. If you want, you can go ahead and cross cancel. So your answer is 25 pi over 6 centimeters for your arc length. It's probably the hardest one on the test because you have to do both steps. All right, number 4. This is our 3rd time through, so we should be really filling in the gaps here. We should be solidifying our understanding. What do I know? I know the cosine is 2/3, which means the secant is 3/2. Now, I need to fill in all the rest of this stuff. How am I going to do that? I'm going to draw a picture and do the Pythagorean Theorem. That's exactly right. Now, here's the tricky part. Where am I going to draw the picture? Look carefully at your problem because they tell you. Where are you drawing it?
2.
Between 270 and 360. But remember, this is not the compass labels. This is our regular trigonometry labels. So where am I drawing it if it's between 270 and 360? That would be quadrant 4. That's quadrant 4. The only time you use the compass labels is when you're on a compass. Okay? If you're just randomly out there in trigonometry land, you're using the regular standard position angles. So your triangle is in quadrant 4, between 270 and 360. It tells me that in the problem. Cosine is adjacent over hypotenuse. So somebody said we're going to draw a picture and do the Pythagorean Theorem, so we're ready to do the Pythagorean Theorem now. A squared plus B squared equals C squared. Indeed, and make it negative. It's actually negative root 5. Does everybody recognize why it's negative?
Going down.
It's going down. Quadrant 4, y is negative. And now you can fill them in. So sine is opposite over hypotenuse. Those of you that are still messing this up, go ahead and label your sides, adjacent, opposite, and hypotenuse, if that helps you keep it straight. So opposite over hypotenuse, cosecant will be the reciprocal of that. And tangent is negative root 5 over 2, so the cotangent is the reciprocal of that. Okay. So when is the only time we put 0 up here? When it's a compass. Yeah, when it's a compass problem. So if you got somebody, if you're giving directions to somebody, like go on a course of 58 degrees or something, that's 0. But otherwise, 0, 90, 180, 270, that's the way it goes. Okay. Now we've got to find the exact value. Remember, anytime it says exact, you need to do it without a calculator and show all of your work. All right? You're not going to get points if you don't show your work, because that's what exact means. So, this means an angle. That's a positive number. So where am I going to draw my angle? Quadrant 1. Remember, as long as this number is positive, you have this inverse notation, and that number is positive, you're always going to draw in quadrant 1. And we know that the tangent, you can make that a fraction, opposite over adjacent, 1 over 1. So at this point, you should recognize that triangle, right? You got a 1 and a 1, that's a root 2, and this angle is 45, and that is the answer to the question. Now this one is not positive, so you're not drawing it in quadrant 1. Where are we going to draw it? Quadrant 2. Very good. Because that's where we draw inverse cosines that are negative. That's our rule. They're in quadrant 2. So this is root 3 negative, and this is 2, and that's 1. Adjacent over hypotenuse. As soon as I put a root 3 and a 2, I knew that was 1. Now you should recognize the angle right here is how big? 30. Very good. But the answer isn't 30. Remember, the answer is that. You have to start at 0 and go around. So how big is that big purple angle that's starting at 0 and going around? What? 120? No?
150.
150.
Wait. I thought it was 90.
Somebody explain it. 180 minus 30. This angle right here,
It's
see
not
where my
90
fingers
plus
are? Look, see where my fingers are?
Mhm.
That angle is formed by this line and this line, which is 180. Does this angle, where my fingers are, have anything to do with 90 degrees? Nope, don't use it. Use 180. The triangle's sitting on 180, so use 180. So you're 30 degrees before 180. Okay? So the answer is 150. The answer to that problem is 150. All right, here we go. Tangent 3 pi over 2. first thing you're gonna do with this? You're doing this exactly without a calculator. What's the first thing you're gonna do?
On the degree.
Find the degrees, and you'll find the degrees the same way we did earlier. Pi is 180, divided by 2 is 90, times 3, I think that's 270. Yep. I was getting ready to do what I always do, which is draw a triangle. But then I realized what about 270? It's on the line. And when you have it, remember this is 0, 90, 180, 270. When it's on the line, you don't make a triangle, you make a circle. Because you can't make a triangle, it's impossible. So we make a circle instead. And we let the radius of the circle be 1, which means this point, here's the origin, it's down 1, so what are the coordinates of that point? 0, negative 1, which means x is 0 and y is negative 1 from that point right there. So we want tangent, which is y over x, so that's undefined. So negative 1 over 0 is undefined. Okay? One more on this page, and that may be all we have time for. I have a hard time keeping track of when these periods end. Okay, here we go. Sine 5 pi over 6. What's the degree measure of 5 pi over 6? 150. 150. So we're finding the sine of 150 degrees. Now 150 is not a line, so I'm going to go ahead and draw a triangle, but I got to get around to 150. So isn't 150 over here in quadrant 2? Because it's between 90 and 180. Now, if this is 150, again, look at my fingers. The angle I'm talking about is between 150 and 180. How big is the angle between 150 and 180? 30. That's a 30-degree angle. So I know the sides of my triangle across from the 30 is always 1. What do I have to be careful of, though?
Negative.
Exactly. There's a negative where?
Root 3.
Root 3. Perfect.
And so anything below that, like, middle line is negative? Right?
No. Anything over here. Left. This is x. These are the axes. These are the axes. So that's the negative x-axis. All right, I need a sine. What's the value of the sine? Opposite over hypotenuse. So that'll be 1/2. All right. So let me make a note of where we stop. Okay,
So the test would be
we're not
negative.
done yet, so your test will be not the next class day, but the class day after that. We'll have to figure out where that is, or when that is.
Mrs.
But
Ford,
we're gonna have one more day to finish this up. Yes?